This video is focused on the shape of distributions. So I'm going to cover symmetrical, different ways that we talk about the shape, like the mode, bimodal, unimodal, and then skewness. I'm not going to focus on normal distributions. So there's a different video for that. So the distribution, the way to think about it is that you're talking about for a single variable, how are those scores distributed? Now, the levels could refer to, if it's points on a test score, it could be each point is a level. It could be every 5 points is a level. It really depends on the variable, but the key is that you're looking at a single variable and how those scores, what those scores look like. So for example, I collected the narcissistic personality inventory scores from students, and I used this data in an example in previous videos. So you can always refer to that. But imagine that I collected this and I had 9 students in my sample. And these are their scores. So student 1 had 16, student 2 had 9, student 3 had 16, etc. Now I could turn that into a frequency table. And so my frequency table would say that I had 4 scores of 16, because I can see this 1, 2, 3, 4, and it would list out the frequencies for each. But I'm just going to go ahead and put it in a histogram so that we can visualize it. So when I talk about describing a distribution, I'm talking about what does the shape look like if you were to graph out those scores. So here you can see that 9 shows up once here because it's once in our data set. So this is the frequency on the y-axis and then the actual variable on the x-axis. So what can we say about this distribution? We could calculate some things. We could talk about the mean. The mean is 14.44. The median is 16. The mode is 16. Standard deviation is 3. So I could say that looking at this information, we can see that it's not perfectly symmetrical. Even if I didn't graph it out by calculating this, if it were perfectly symmetrical, the mean would also be 16. So this tells me a little something about this shape already. And then our standard deviation is 3. That means that on average, our participants vary by about 3 points on the NPI scale from the mean of 14.44. So our mode is 16, right? So we know that this is unimodal. There's one high peak. Is it symmetrical? If you cut it in half, fold it over, it's not really symmetrical, right? Because this one's a lot higher. And this is such a small collection of data that this really doesn't fit what we would picture as perfectly symmetrical, but it's like kind of almost symmetrical. We have the same on either side here. It's like almost bell-shaped. There's not really any outliers. So we don't really have any really, really far away values on the tails. Let's say that I had a 0. That would be an outlier because it's far away from the other scores. And there's ways to calculate your outliers. You can set boundaries for them, but we can just look at this and say we don't have any unusual values. And then we talk about the negative tail and the positive tail. So negative tail is the end of the distribution that goes towards the negative y-axis, and then the positive goes towards the positive y-axis. Oh no, guess what? There were actually 10 scores. I forgot one. So now we have a score of 36 that should be in there. So instead of having a mean of 14.44, our mean has increased by 2.2 points, basically. Our median and mode stay the same, and our standard deviation has increased a lot. So now we have this really high score, this person who scored very high on the narcissistic personality inventory. Their score is now pulling the rest of the mean up. So it's made the mean higher. So this outlier is pulling the mean up, and now we have a positively skewed distribution. So to explain this in a little bit more detail, I have a picture of each of the distributions, and I just drew a curve over them so that you can kind of see the shape and how it changes. So this is our first example where we had our 9 scores. Our mean was 14.44. Our standard deviation was 3. The median and mode are 16. And you can see here that this shape is kind of leaning towards the right a little bit. The majority of our scores are really in this right part here. But look at our mean. Our mean is 14.44. So actually it's, to the right of this value. So we have the 14 score, the 2 12s, and the 1 9 are all under this mean. And then the 4 16s and the 19 are above the mean. Now, what happens if we add another value over here? So we have this NPI score of 36 over here. It's created this outlier. We pull the mean up. So the mean is now at 16.6. It is above the majority of the scores. So now only 2 scores, the 19 and the 36, are above the mean. So a positively skewed distribution means that you have an outlier that's pulling your mean higher positively towards the positive side of the axis. To demonstrate this a little bit more, I created some graphs here so that you can see negatively skewed, positively, and symmetrical. So I'm going to start with symmetrical. Symmetrical here, we have a mean of 13, a median of 13, a mode of 13. This is not skewed. They're all the same. If your mean, median, and mode are all the same, then that is a symmetrical distribution. So that information, you can see that this is a symmetrical graph. Now our negatively skewed, we have an outlier that's pulling our graph pulling our mean to the left. It's making it smaller. And so what's happening is that our median and our mode, the majority of our values are above the mean. So you can see that there's more of the scores that are above the mean here. So that's negatively skewed. And then in this example, we have positively skewed where we have a really high score. It's pulling our mean up, and now the mean is higher than the majority of our scores. You can see here that the majority of the scores are below the mean. So they're not going to look exactly like this, but the way that you should think about it is, are there values that are pulling your mean up or down? And the median and mode are a really good way for you to see what's happening in your data compared to the mean. So again, if you have a perfectly symmetrical graph, then your mean, median, and mode should all be equal.